Hi there, Carlos. This is Philip. Hey, you want me to do the little quick intro here? How about that?
Yeah.
We have with us Carlos from IOHK, and he is the director of their project that has taken near-field communication cards for shoes for a manufacturer and actually turned that into a way to prove authenticity of the shoes. And we're going to play a video here in a second that is the kind of my overview of what we're doing in the Wyoming research lab with this to get better security on the proving authenticity of products. So if you'd play that video, or do you want to go ahead and talk for a second, Carlos? Yeah.
Yeah. So after that one, we also prepared a video for you on what are our core thoughts with regard to product authentication. So hopefully nurturing a very healthy and interesting discussion after the fact. So we'll play those two videos and then we'll open the panel for further discussion. Thank you.
Okay, perfect. Let's go with the video. Well, hello, I'm Professor Phillip Schlump. I'm one of the researchers working on a piece of the hardware in the Wyoming Blockchain Advanced Research Lab, WABL. And I want to talk to you a little bit about what we're working on and why it's important and what the impact of this is, because this is a big field. This is way, way more important than I was certainly thinking about. Now, I knew there were some counterfeits in the world, and I've been to Kuala Lumpur and gone and bought a $14 knockoff t-shirt that's $50 that has, Mickey Mouse on it, and there's the Mickey Mouse thing on the front. It wasn't very good quality, but it was a knockoff, and hey, why not? It's a t-shirt, It's not like Petaling Street or any of these black markets are really having that much impact on Disney. Disney's profitable. I'm a shareholder. I get the quarterly and annual reports. So, you think about it, and you ask people in general, counterfeiting, and that's their impression of it. It's t-shirts and a few things like that, but it's not really that important, and they don't put much credit in it. It's just not really on their radar how prevalent it is. But let me tell you something about Mickey Mouse. Mickey Mouse is not Mickey Mouse. Mickey Mouse is a multi-billion-dollar asset of the Disney Corporation. There's nothing Mickey Mouse about Mickey Mouse today. And there's nothing Mickey Mouse about counterfeiting either. And when you start looking at things, for instance, $12 billion a year is what they're tracking currently in counterfeit car parts. And, you go buy a counterfeit airbag, and I think in the National Transportation Safety Board's discussion, it was more likely to kill the passenger than save the passenger. Or counterfeit brake pads and counterfeit brake lines. There are a lot of things that you can put on a car that if it's a counterfeit, you're risking people's lives. And most people are not even the ones that are purchasing the counterfeits. You go to some auto shop and, this little auto shop says, well, I can spend $100 over here for a real part or $15 for a fake part, and I can pocket the 85 bucks. And that's the primary way that we're seeing counterfeit parts show up. 70 billion a year, 75 billion a year in fake medicine. Now, there's the good, the bad, and the ugly about fake medicine. The good about fake medicine is that 70% of this bunch of medicine has no active ingredient at all. And with no active ingredient, it isn't killing anybody. It's the ones that have, lead and arsenic and other things like that in it that you really have to worry about. Let alone the fact that you're taking these medicines for a reason. And with no active ingredient, they aren't making you better either. So you start looking at these different categories. 20 billion a year in fake sex toys. Maybe sex toys is not your favorite thing, but that's a lot of fake sex toys. And again, this is something that if it's not built right, it's dangerous and it will kill people. And SpaceX had a $68 million failure on a single launch because of a fake strut inside a fuel tank that was not an original part, that was a fake substitute. So, you know, fakes. Bad things happen when you don't use real products. And when you start adding up all of these different things, Harvard Business Review says that, you know, across the set of these things, there's something amazing like 5.4, and you don't see this number too often in terms of business stuff, trillion. That's not a billion, that's a trillion. $5.4 trillion a year in counterfeit goods. And 70% of it is in luxury goods. And what can you do about something like this? I mean, this didn't used to exist. Okay, we have the rise of the internet. Manufacturers, fake manufacturers, can go out there and sell something and sell it across the internet. It has skyrocketed. So this is a new problem. But yeah, what do you do about counterfeits? Not just the dangerous stuff. And sometimes counterfeits are huge. Like, I see a recent article that there was 38 million pounds of counterfeit corn. And you go, what's wrong with the counterfeit corn? Well, we're feeding it to our animals, and the animals are not being healthy because this was bad corn. And when you're talking 38 million pounds, suddenly it starts becoming really significant. It was all animal feed, but even so, that's a huge, huge problem. So how do we address this problem using a blockchain? What is IOHK and the lab doing about this? Charles Hodgkins put us in the direction of going down some research with near-field communication chips and figuring out a way to make near-field communication chips. And the critical point here is that a lot of these things, you have a manufacturer that's doing a legitimate run at the beginning, and then they turn around and they substitute some other things and they do an illegitimate run right after it. And if all you're looking for is, does the box look legitimate? Well, guess what? They're just going to print some extra boxes, and they're going to sell it, and they're going to pocket the money. So you can't just look at the box. What you need is something that can't be duplicated, can't be counterfeited easily. And the way to do that is to use some cryptography, namely a digital signature that proves authenticity, to put it into hardware where the private part of the digital signature and the secrets is in a secure computing environment so that it can't be extracted from the hardware, and then to attach this piece of stuff to the product so that, you know, you go in and you buy some medicine, you can take your phone, and there's a reason why I say your phone, and you can like RF scan this thing, and you can say, yeah, this is this product. It was manufactured here, it came from here, this is where it came from, and here's what the product is. And you can look at the product and say, yeah, it's that product. I mean, yeah, these two match. Now, for luxury goods, there's some other twists that relate to the blockchain, but we'll get to some of those things. So you want a protocol that makes this happen, and you want to make certain that that scan is unique and can't be forged easily. And that requires more than you see in standard RFID and NFC chips. So this is a new kind of a capability. And then you design a protocol around this new capability, and you say, what else can we do with this protocol? Let's take a closer look at some of the ramifications. Now, for various reasons, I was able to ask specifically about medicine with the former head of the FDA, previous government's head of the FDA. And I asked him, with all these forgeries, what is the legal ramifications? And his comment was, well, if a pharmacy, okay, and these are drugs that just don't show up, they come by and large from pharmacies. If a pharmacy sells a counterfeit drug, then the pharmacist is legally responsible for that. And so I started researching into the legal liability, and in fact, retailers by and large are legally responsible for any counterfeits that they sell. If you go and look in US code 2320, okay, and you look at it, for selling counterfeits, you can receive fines up to $5 million and up to 20 years in prison for, you know, selling that counterfeit. That's pretty serious legal liability. And his point about being able to track something like this is that the instant you can track it and prove it, right now nobody can say, did they or did they not sell a counterfeit? But the instant you can track it and prove it, that legal liability becomes real. That suddenly the retailers have to respect real products. They can't get by without it. And if they don't, here's the proof. Here's what their liability is. With the near-field communications, I'm talking about a little tiny dot like this. This is a near-field communications chip. I haven't peeled it off and stuck it on anything. It's got a little sticky background. It's a little circular jobby like this. Okay, but if you look at it, in the center of that little circle jobby, the circle is an antenna. In the center of that little circle, there is a tiny little computer. And that is also true for things like credit cards, where when you look at a credit card, on the back of it, I don't know if I can show you this, but on the back of this credit card there's a little tap and go symbol, which means this thing has near field communications capability, and you can go in and do contactless payments and pay for things contactless. Now, both of these, okay, I'm going to be doing a demo that describes it as a card. I'm going to emulate this card. And the emulator is not a small in-the-card thing, because it's going to take a lot of work to get from hardware to the point where instead of it being hardware, it is, you know, down to the size of one of these chips. What we have to do, and this is actually a picture of my emulator here, not plugged in, but what we have to do is we have to take the capabilities of this and put it down into an ASIC in a single chip. So when I run my emulator and give you a demo, what I'm demoing is this running, but this thing doesn't have a user interface, and consequently you can't see what it's doing very well at all. So that's what I'm going to demo, but that's coming up. Now I want to talk a little bit about the protocol. What makes this work? The near field communication protocol, we're using NDEF as the underlying electrical protocol. But what I'm going to demo to you is going to have an emulator that basically is the same as the card. Okay, that's this piece right here. And unlike the card that has no user interface, this one actually has a button on it and an output window so you can see what's going on. So that you can actually see what it's doing with the card. And the emulator is running on an iPhone. Might have switched that around. This might be the Galaxy and this might be the iPhone. But it's running on a smartphone. We have the reader that does a verify button. And it has a window that can actually print out information about the product. And the other thing is a programmer. The programmer is the one that we use to set up the information in this card, to create the card in the first place. So at the beginning, we're going to come over here and we're going to program the card. Now once the card is programmed, you can't program it again. You can go over here and try, but it'll just reject it, reject it, reject it, because once it's written, you can't change it. That's an important property of these cards. Now who does the programming? The manufacturer? Maybe. Or the people who actually built the card or the chip that's going to go into the product before it ever goes out the door? It's a good question. I don't have an answer to that yet. Now, the reader, the reason why I'm using an iPhone or an Android as a reader, a smartphone, is at least in the United States, 96% of people have Androids and iPhones that can read near-field communication cards. So the ability to be able to read one of these is critical if you're going to get it out to the market where people can actually use it. And this answers who has the readers. I mean, who has an NFC reader? We all do. We're carrying them around in our pocket. We just don't know what the capabilities of it are yet. So this is kind of the demo. Now what happens? I drew you an arrow. This goes out and writes it. It writes it one time and it puts some information in there. It's putting in a public-private key, and it's also putting in a thing called a nonce, which is a number that's going to count up. Okay? And it's also putting in a secret. And each one of these things in the protocol serves in a different way. So later, when the verifier comes along, it can do the work of verifying this with the blockchain. So these are what gets written. Now, the private key and the secret are secrets. And that's the stuff that has to go into the secure storage inside the chip. The public key is public. So we use them together, and the nonce gets updated. It increments each time we do a verification. So the nonce provides us another kind of security, and it is also used in the encryption process to guarantee that things change so that you can't duplicate the communication. If you've got another reader out here and it tries to do it at the same time, we're going through the mathematical formal proofs right now to show that this guy can't do this, and to prove mathematically that the protocol that we have between the reader and the writer here actually works. So the reader, okay, goes out and it talks to the card and it reads back information, but when it does it, guess what? This guy makes some changes, that nonce increments. And it sends back a digital signature. The digital signature inside here can then be checked. The secret and the nonce can be used to verify that this is in fact unique, that somebody else isn't interfering in our communications. And when we get done with the reader, we can say, yeah, this is valid. Or, nope, that is not a valid key. Now, that's only good in terms of, it's a number. I can validate, I can pull up the product information. But the question is, what is that product? Is it a shoe? I'm actually using a test example of a handbag because it falls in the luxury category. But, yeah, what is that product? And does that product actually match with the physical product out here? If it has a serial number, does the serial number actually physically match? Now, the computer can't do those things very easily. But the human being can look at the picture, see the product description, and go, I'm holding a handbag that was sold for $3,000, but it says it's a shoe, and those don't match. So the human being can actually verify some of this information for us in a fairly obvious fashion. So this is kind of the protocol. Now, on one side of this, we're talking to the card out here, and on the other side, we're talking out there to the blockchain. And pulling back information from the blockchain that allows this to happen, allows our secret and our one-time password verification to take place and be unique, prevents other people from interfering in our communications or duplicating the communications and using it again. So the blockchain provides a critical piece to this entire picture. Now, there's other things we can do with this protocol. There's a way that we're looking into for using the same protocol, but instead of a card out here, we actually do use an emulator, and then you can use it for things like remote doors or remote access. Or, yes, here's an idea. If you actually use an emulator like this, you can use keyless entry to your car, and right now one of the big problems with keyless entry to cars is somebody with a big antenna can sit across the street, listen for you to push the button once, and then later that night come along and steal your car because they can do the same thing over again and start your car. This would prevent that kind of an attack. So that's the underlying protocol and some of the capabilities that we're looking at and researching in the lab. And to put it in perspective, something like this gives attestation to the fact that this card, this little chip, whatever it is actually real and not fake. And that's the critical piece to the whole process. Okay, on the left we have an emulator for an NFC card. Now remember what I said about an emulator is that it's not real because the real card doesn't have a user interface and you can't see what's going on. In this particular case, the emulator has a capability the real card doesn't have. You can reset it and start over. But it also has a test button to internally make certain that it's talking correctly to the different pieces of hardware. So if we click the test button, it says that it's working. I know that's not much output, but yes, it went out and it tested its behavior internally and made certain that the software is working with a bunch of tests. Now, the first step in doing a card is let's start out with a fresh card. It's reset. Let's set up a card. The particular card I'm going to set up, once it is written, is associated with a woman's purse. And this is permanent. If I sit here and do setup again, it fails. The card is already set up. You only get to set it up once. So we've set up, you notice the programmer over here says failed. It can't do it. So once the card is set up, it can now be, I say card, but the NFC chip is set up. It can be used to validate whatever the device is, whatever is inside the card. And this validation over here is done with another phone. And when we do it, it goes through a process whereby it goes out, it picks up a bunch of information from the NFC across the NDEF protocol, uses that information, generates a signature, and then takes that signature and that information, goes off to the blockchain, looks on the blockchain to see if this is the first time that signature has ever been used. And then if it is, and if the signature is valid, it takes that information, looks up what is the associated product with that, and we get back that it's a Prada medium tote. And in fact, I've put into the information that comes back with it the URL of an image, and it displays the URL of the image. So you actually get a picture of what it is that you're verifying.
Hey everyone, so today we'll talk about product authentication. All right, so if you have seen my presentation on the Cardano Summit, this is a similar, we'll go through a similar set of topics, but I want to deep dive a little bit more on the logic behind some of the decisions or the information that is in the presentation. Hopefully nurturing an interesting discussion after this presentation and in the conference, and maybe even after the conference, hopefully. So let's talk first about market problems. So the first one, of course, I mean, obvious pick for the first one, luxury markets. So counterfeit is a big problem in the luxury market. In some accounts, have estimate under some accounts, there's it grows up to exceed $3 trillion globally. Now, one big issue with that is a good portion of it was an issue before Corona in the online retail sector. Why? Because it is very hard to tell who you're buying on some platforms. It is very hard to tell who you're buying the goods from in an online, in an e-commerce sector. The other thing that goes hand in hand with this is that usually the process of dealing with counterfeit is lengthy and somewhat ineffective, budget draining, and so on and so forth. The next one is arts and collectibles, where, as you may expect, there are many, I mean, plenty of reports, a significant amount of reports on forgery and on. The last but not least of this specific set is not an exhaustive list, but last but not least, we have pharmaceuticals. Pharmaceuticals have two problems of fraud, we can say. It is not only counterfeit of medicine, it is also contraband. Why contraband? Because countries have different prices, and sometimes even countries are share borders. So it is just generates big incentive in between borders if the price difference is enough for people to, of course, steal in one, take it, transport it to the other, and sell it in the country with a higher price. All right, so the issue. Okay, one last thing about, because the time is going out too quick. One last thing about this is that the issue in the pharmaceuticals can become very easily also a health issue, because some medicine needs to be transported following a series of guidelines for it to be effective, like temperature, just to give you an example. In contraband, of course, doesn't follow the guidelines, doesn't have to follow the guidelines. All right, now, before we move to the next slide, one specific topic in underlying all these industries. Like these industries, they share a commonality, an obvious commonality. The cost of producing a good, the real cost, materials, process, and the willingness to pay. There is a big gap between those two. Margin is big. Big enough for a counterfeit operation to get in the middle, even being more inefficient, in being having higher costs than what the legitimate manufacturer does, but the gap is big enough for you to have not only just a high incentive, but also to be a little bit sloppy in here, increase your costs. You still have a huge room to maneuver. So, okay, the problems for the business. So problems for the business are, this is not an exhaustive list, but we highlighted here for the fact that the current processes are inefficient, the fact that the risks, if a risk becomes real, then it is a huge deal. The fact that the brands lose control of the customer experience because the customers are fooled when they buy a counterfeit good, thinking that it's a real good, and then if they have a bad experience with the product because it was not manufactured in the legitimate, utilizing the legitimate process, then that damages the brand in a way that the brand is very hard for the brand to control or mitigate the damage. Okay, so there are different reasons why this is such a big problem or a big deal. One of those, and it will be different depending on the market because situations are different. But there's one reason, one set of reasons. Let me just give you an example of the luxury goods. Like if you're a luxury good producer and you're outsourcing your manufacturing process to low-cost geographies, what prevents the factory to do a factory overrun? And instead of producing 100 bags, they produce 150 bags, and they sell the extra production outside of the factory. Even if they don't utilize exactly the same input materials, they utilize similar materials that to the naked eye are exactly the same, to the naked average eye. So, and that is a trend that you could see over the past decade of the luxury brands, a disconnection between the brand per se and things like the provenance of it. This is a luxury brand because back in the day, luxury brands were produced in a specific place, usually Europe, and that gave a little bit of a status to it. In the past, also, some of these products were even tailor-made, handmade by people that gave a little bit of scarcity, a little bit of exclusivity. But there has been a trend of outsourcing that manufacturing process to lower cost geographies as well. And hence, when you start dividing the brand and what is being the brand from the physical product, then it is even it makes it harder to actually control what happens with fraud and with counterfeit goods. All right, so let's talk a little bit about what we are intending to do. We intend to nurture with the TileScan what we call the next decentralization level, which is we allow the different parties in the different parties in the market to interact, to contribute with data, with actions. We allow the people buying the good to actually attest on some information that is publicly available, effectively decentralizing a little bit the process of authenticating the good. All right. We want to empower users to secure their purchase, to verify before they buy, and provide a little bit more data what's going on the market in general, to the interest of the brands, of course, and the end consumers. So once you allow the end consumer to have a protagonist role in the authentication process, many different interactions can become possible. By the way, blockchain is a technology that, it enables many different types of interactions between the players, privacy preserving, without the need of intermediaries. There are ways of entrusting that to bring trust to the process and transparency to the process, and so on and so forth. But there are also other advancements in other technologies that are trying to get a new look at this same old problem. For instance, there are solutions out there that utilize artificial intelligence and the natural entropy of the materials to fingerprint the goods, and hence with power of the cell phone cameras that you have nowadays and the power of the devices that you have in hand, there are ways of verifying the goods, that the goods are authentic, and so on and so forth. There are also technologies around secure QR codes and so on and so forth. The way we look at it, like how you do how you bridge the gap between the real world, like the good, and the digital world, is not, it's just one side of the problem. The other side of the problem is how do you nurture interactions between the players so they all become part of a stronger or more trustworthy system. Like, for instance, if you allow people to authenticate the goods before they buy, but it never gets, like, that small little process never gets into the decision-making process of making a purchase. Like, one thing is to have the possibility of doing it. Another completely different thing is that I, Carlos, before I buy a bag, I download the application, I learn how to use it, I do the activity, and depending on the result of that activity, I buy or not buy. That's entirely, like, that's changing a habit. That's changing the way you purchase. So it's all about, like, for us, a very important fact is all about the interactions that you provide while you purchase, after you purchase, and on, to nurture that that ecosystem of different players collaborating to finally, at the end of it, solve this problem. All right. Okay. All right. So, well, next slide is a little bit more about our solution, but I just found out that I ran out of time. So, I mean, it just talks about what we allow the traceability products, the authenticity check of the products. One of the things that we do is that we separate the concern of bridging the gap between the product and the digital world and the digital world per se. Like, if you want, you can authenticate through a varied set of chips, right? And depending on the manufacturing process, you select the chip and so on and so forth, or utilize other technologies. All right, that's it for me. Thank you very much, and I hopefully this helps kickstart an interesting conversation.
Hey there, Carlos.
Yeah.
Yeah. Okay, first of all, we should probably ask if there are anybody that has any questions. Okay. If there are, I will bring up my chat, and if you put it in the chat, or you can turn on your audio and ask. Actually, if you put it in the chat, that would probably be the best thing for questions. But yeah, that's what I'm expecting. Yeah. If and I do not have the virtual chat up. Okay.
I do. I am so I'll be watching. If you have any questions, I'll be here, and we can take them.
And Carlos, you ran a trial of the very first version of this with Adidas, I think it was, and
with New Balance.
New Balance. Okay, I knew it was one of the shoe companies. I apologize to everybody that's offended that I picked the wrong shoe company. With New Balance, and I know that one of the shoe companies reported that they think they alone have $200 million a year in counterfeit shoes being circulated in their marketplace. So even in shoes, this is a huge, huge thing. And they were only reporting what was in new shoes. I don't know. What did New Balance say that they have?
Yeah.
Did they
So
divulge?
the the problem in shoes is very interesting. I mean, generally speaking, because a good portion of the problem remains in how the end consumer is making their decisions and why they are consuming the goods that is produced by the manufacturer. In the case of shoes, for instance, it's very interesting that some people intentionally buy counterfeit shoes because they are cheaper, and I mean, it has gotten to a point that they are of a certain quality. There's documented events or even groups online where you can ask to a particular set of companies to copy a specific a type of shoe for you. So we need to understand that the market, there is a lot of opportunity in the market because it is not, I mean, people are getting fooled, and that's for a fact. But we also need to realize what exactly um, what segments do exist, so it tackles the right segment. Like if you really and intentionally are looking to buy counterfeit goods because they gives you certain status, you don't want or you couldn't get the real one, then that's a purchase decision that will be very difficult to change. But at the same time that we have that population, we also have the set of population that gets fooled, that gets framed, like, you know, that's is subject to fraud. So we have two questions in the chat. The first one is, what are the largest barriers to adoption? What would you think on that, Phil?
The largest barrier to adoption is the fact that nobody has actually built some kind of a device that has provable authentication that you can actually prove is real. And you would think that something as expensive as a car, they'd actually have a device that can't be just replayed and start your car, and so somebody can open the door and drive off with it. But these devices don't exist yet. And you look at physical door locks, and one of the first tests that I did with the emulator was I duplicated the University of Wyoming's door lock, and I walked up with my phone with the real one in a steel case in my phone, and I can immediately open the door. So, you know, it doesn't work either. And all I did is duplicate the RFID chip inside. I tried the same thing, I will admit. I was with my credit card in my hand, but I scanned my phone on a near field communication to verify that really wasn't updating or doing this. And then turned right around to make certain there was no change. And I bought a pack candy bar at a grocery store. And it works the same way. I mean, they do not update, and, you know, I'm not some magical person that has great background in hacking into credit cards, but it shows what's going on in a very, very simple fashion that, you know, the security is not there. And if they're not getting the security for things like credit cards and cars, you know that they're certainly not getting it for anything else.
Yeah. So we already ran out of time.
Okay.
Yeah. So
yes, okay. Thank everyone for attending very much. And Carlos, I think your presentation was wonderful. Thank you.
Yeah, likewise. I'm sorry if, because we heard from the moderator, and I believe that the audience is not hearing that, so it was a little bit there was a little bit of a gap in there. But yeah, thank you very much, Phil. It's very exciting, the technologies that you're working on. Again, for me, what is crucial is how to pair these technologies with these hardware technologies with software technologies and protocols like blockchain to enhance the customer experience so much that we can influence their purchase decisions. And that's when we will make a change.